Hello, everybody. Thank you so much for joining me today, and welcome to today's masterclass on MATLAB for analyzing and visualizing geoscience data. My name is Loren Shure, and I've been at MathWorks over 30 years. Some of you may know that my background is actually in geophysics, as it is. And today I'm going to try to share some of my knowledge, as I do in this whole sequence of classes. And in addition, you might think about looking for useful MATLAB tips on the blog I maintain, The Art of MATLAB, on the MathWorks website. Now let's go on to the seminar content. Okay, so today what I want to do is I want to show you how I can build an interactive map containing information about geospatial events. And then I want to get into the topic of how do I handle large amounts of data, because let's be honest, that happens to us in geosciences a lot. And then a little bit about the community resources that are available. So the first demo I want to do is trying to research earthquakes from around the world. And these are going to be recent ones. Let's suppose I want to find out around the world for the past 30 days, how many earthquakes, what the earthquakes were that were magnitude 4.5 and above. In other words, ones that maybe felt a little more broadly than just locally, potentially. And then I also want to think about where those earthquake epicenters are in connection to tectonic plate boundaries to see what's going on. So I'm going to come over to MATLAB now and show you how I would explore this. Here's my MATLAB desktop. And I am going to take a minute out and say something, because one of the things you see here is I am actually using an editor now, but I am not using code that is traditional MATLAB code. In other words, code that ends in a file name with .m. You'll see this document ends in .mlx, and I've made this my editor to be the size of my desktop, my MATLAB desktop here. And you'll notice that there's a live editor tab here. And that's because in this case, I can come into this document and not just put code and comments, but I can put formatted text, and I can put all kinds of fancier things, controls and tasks in there. And I might even want to put some mathematics in there. Now, I don't have any mathematics specifically to share with you today, but I want to show you what might happen. So I can put in a picture, I can put in a hyperlink, as I've done here, to show you where you can find out information about the feeds that I'm getting from the US Geological Survey. And I can put equations in, and I can either use TeX if I want, but I'm not so good at it. It didn't exist when I was finishing my PhD just a few years ago, of course. But I can use the equation editor, and I might want to put in anything, any sort of mathematical symbol from the keyboard, but also the Greek alphabet and other kinds of symbols that we may know. Whoops, sorry about that. Let me come back to here. I have compound mathematical symbols I might want to look at, and I might want to be able to put in a matrix. So in fact, I'm going to put in a matrix here. And the way I put things in is I can either point and click, I can say theta here, or I can say X, and if I know the LaTeX, which happens to be up arrow there, I can put it in. And I can put in one of these complex ones or compound ones. I'm going to take the nth root, and we'll do the third root of x cubed. No, let me go back. Let's do 3x to the 17th minus 3. Okay, and so I can put in mathematics, and the reason that's so crucial is because this document I'm creating is code, but it's not just code. It's a tool that you can use for collaborating, for you can, for example, share some code with someone else, maybe with your MATLAB drive, and go back and forth and edit it. You may want to actually just show the output of all this. Suppose, I know I haven't showed you how to run anything here yet, but suppose I do run something. When I get all done, I can choose to share my document, my MATLAB live script here, either with someone else who has MATLAB and just give them the live script, or I can come here and I can save it as I can export it to PDF, Word, HTML, or LaTeX. And so it's a really nice way to share the results that I have with other people. So that's one part of collaboration. There's other ways to collaborate too, of course. And maybe I'll point them out as we get along. But if you can put the equations in, people can then check the code to make sure the equations match the code you write, and so on. So, but I don't want to do that. What I want to do here is I want to come and I want to get the last 30 days of data from the USGS that are magnitude 4.5 and above. And so just in case I'm not online, I just have this extra, in case I'm not online statement, I have some data saved. But what you're going to see is I'm going to take this section. Notice this section had regular text. It had titles and subtitles and normal text, and it also has code right here. And in order to run this, I can come to the live editor and I can just say run the section. And now it is running the section. And when I do, I'll show you in my workspace, I now have some data. Now, what did I actually do? Well, I used a web read. Well, if you haven't heard of web read, it might be interesting to find out what that is. So let's get the help on web read. And I'm opening up the MATLAB documentation here. Let me make it a little bit bigger because I know you're looking through perhaps a small screen. And if you have not used a lot of our documentation recently, I really urge you to look at it because we've spent a lot of effort trying to make it better and better and better. And web read says that we can read content from a RESTful web service. There's 2 or 3 things that I love about the way our documentation pages are. First, and these are not in order of anything, just there's a few of them. Examples. If there's an example that read image from a website, read, whatever, any one of these, I can just look at that particular example and then I can maybe copy and paste the code and put my own URL in, and then I'm ready to go and go on with my project because I've been able to get data. Another thing that's extremely useful is looking at the see also. The see also will tell you many things. When it got introduced into MATLAB, other functions that you might find interesting. So as well as web read, we have web save. And if I open web save, what you'll see here is instead of reading it, it will allow me to save it on my hard drive so that if I become disconnected later, I can still analyze that chunk of data. And then you'll also notice there was a web write, and then some topics in the documentation that may help me. Okay, so I'm going to put that aside right now. So I just read in the data, and it's reading it from a JSON feed, basically. And I'm going to take the information that's in the data, and I'm going to separate it into 2 pieces. I'm going to take the feature with all its properties and put it into the information about the earthquake. And the location stuff, which is the geometry, I'm going to put in a separate variable at the moment. And so I've got some new variables here. And what I want to do is I want to take the information that's in this structure. And remember, everything that's in this structure is really all going to be the same format. So for every quake, it's going to have something about the epicenter and something about where it was and whether or not it introduced a tsunami and things like that. So it's going to be a very regular format. And because of that, I can convert this structure to a table. And so that's what I'm going to do. Tables are a relatively new construct. They're not that new anymore. But the first column, if I take a look at quake table, let me go like this. Let's open it. And quake table is a table. And you can see there's 451 events. And it says it's times 25. So I have 25 columns here, the date and time. And of course, I can make this column, wider so you can see it. So you can see the date and time, magnitude, a place, time zones if it's needed, but since everything is in, I think UTC, it doesn't matter, whether or not it was felt, and a bunch of information about it, the magnitude type, how it was derived, and so on. Okay, so that's what a table is. It's basically an M by N array, just like a regular MATLAB array, only notice that the columns need to be uniform per column, but each column doesn't have to be the same as the next one. So if I just come back here really briefly, you'll see some of these columns, like tsunami, felt, was either 0 or 1, but the network is in string in quotes. So I can have strings and numbers together in the same data structure, if you will, there. So when I get the time though out, boy, this time looks really strange. And that's because it's POSIX time. And so what I'm going to do is just convert the time from POSIX time to time that we understand. And I'm going to show it to you in the table. And now this is time that we know how to read. And so we can see the different dates and times here. And you can see the magnitude, the place, and so on. And so MATLAB will have all the columns, and you'll see that I can scroll to them in this document and see what's going on. Now, tables are super, super useful. And so I can find out more information by finding out what variables are in the table. And so we can look to see what they are. And I can actually take my equation coordinates from the other variable that I put them in, the location variable here, and I'm going to get from that longitude and latitude. I'm going to take the longitude, latitude, and depth and place them also into my quake table. Now my quake table here, if we look, it says it has 25 columns. When I do this and I'm adding 3, it now has 3 more columns. The final ones are if we look here, the final ones are, whoops, my longitude, latitude, and depth. Okay, so let's just take a quick look at the first piece of the column, one of the columns, just the magnitude. Notice I can get to the magnitude. I don't need to know whether it's column number 5 or 17 or whatever. Although if you know what the number is, you can use that instead. And these magnitudes are not an ordered list because I think the list is actually sorted probably by time. But what I can do in this case is now I can choose for my month to sort the table by magnitude, and MATLAB will keep everything else in order. And now you see the top 5 magnitudes go from 6.1 to 6.9. So a couple pretty big earthquakes this past month. Not the biggest we've ever seen. The biggest one right now is the last one. So I'm just using regular MATLAB, excuse me, regular MATLAB indexing into my table. And I'm saying, tell me what's in the last row of the table. And then I'm saying, you know what? I want to know what's in these 4 columns, but I don't know what their numbers are necessarily. So I want the place, the latitude, longitude, and depth. And when I run this, what you see is we found out that it happened on 18th of September, 9 in the evening, central mid-Atlantic ridge, latitude 0 degrees, so pretty near the equator, longitude a little bit west of the Greenwich Meridian, and fairly shallow 10 kilometers. I think it's in kilometers. Okay, and what I can do if I want is I can shift the dates and subtract a calendar month and make sure that we have a month's worth of data. And in fact, it's going to trim a little bit of data off. I had a little bit more before, and it trims 1 data point off, but that doesn't matter for what we're doing. And now I want to find out what's the smallest and the biggest magnitude earthquake, because what I'd like to do is I'd like to make a plot, and I'd like to make a plot that's meaningful. So I'm going to add color to help me understand which of the earthquakes has a large magnitude and which one might be small. So what I'm going to do first is I want to show you the color map I'm going to use. And I'm going to come here, and instead of using this blue area and using my mouse to run it, I could either run a section here, and I can also, you'll see I can run the section in advance, and you'll see I already added that to my quick access toolbar here. So if I choose to give more space to the editor, I still have access to run in advance right now. So I'm going to run that section in advance. And when I do, it's advanced at the next one. And I want to show what the color map looks like. And here it is. And you'll see it's going to go from a dark blue up to yellow. And we did a few years ago in 2014, change the default color map because our original one way back when went from red through the spectrum and back to red again, which meant like if you saw something that was red in your plot, was it small value or was it a big value? You didn't know. We also know that there's many people who have different kinds of vision issues, various kinds of color blindness, for example. And so making something that you could see equivalently, if we convert this immediately to grayscale, it would look from like it was going from dark to light in a grayscale as well. So that's why we chose that new color map. And then I'm going to just take the names from the title in the Quake table, and I'm going to convert my my Quake table into points, locations that we can map. So I've got these geo points, and now what I'm going to do is instead of plotting it in a MATLAB regular MATLAB figure, I'm going to use one of our a web map to plot the earthquakes. And what it's going to do is it's going to plot this in a web browser, and you can see it's got a base map here. And it's just taking it a moment to get all the data in there. And now each one of these little markers is a location of where an earthquake happened in the last month. I can click on them because I put that information into my geo points, into the data I'm plotting, and it tells me that this one's in Tanzania. And we actually centered this originally on the one that was the biggest one. It doesn't look centered anymore. I already moved things, but here's our 6.9 magnitude earthquake on the central mid-Atlantic ridge. It is slightly below the equator and a little bit west of the Greenwich Meridian. And you can see there's a bunch of fracture zones in here and the mid-Atlantic rise as well. And this is very handy if I want to superpose many different kinds of data. So let me show you how this web map works. First of all, I can choose any one of a number of underlying web maps. So I could put, for example, world imagery, or I can do a National Geographic map. I'm going to come back to the ocean base map because many of our earthquakes happen near ocean basins, and that's helpful. You'll notice also that my quakes are in there, and if I wanted to, I could turn them off and on. And then some other things come, and I could put world boundaries on. I can also, just for grins, put on the NexRad radar and find out for the US. And indeed, I was told that we have a storm coming here in the Northeast later today. So I can basically manipulate the information on the map. And you'll see I can also pan and I can zoom in if I want. Apparently there was another earthquake, not as big as our biggest, 6.9, but a 6.2 earlier in the month as well. So near in Chile. Okay, so that's our web map. And now I want to think about where are these earthquakes compared to the plate boundaries. And so what I did was I found from I'm in the wrong folder here. That's okay. I found from one of these, from looking that there is a location at the University of Wisconsin, it's listed here, that has a data set that includes the locations, latitude and longitude for the boundaries for the tectonic plates. So let me just open this. And when I do, you'll see it has a little notation up here. That's for the beginning of a boundary, and then latitude, longitude, and it goes on for quite a while. And if I were to scroll far enough, I just saw one somewhere in here. There's another plate boundary. So I've got these plates separated by a line that has some numbers, and I get all the different plates in there. Well, I would like to import that into MATLAB. And in order to do that, what I'd like to do is point out that if I have my tool strip available here and I'm on the home tool strip, you might notice that if I zoom in here, there is something on the home tool strip says import data. So if I don't know how to read in this file or any other kind of file, it's an opportunity for MATLAB to perhaps help me. And so let me show you how I could do this. I'm going to take that all boundaries text file, and MATLAB is going to do the best it can to try to understand the data. And it thinks there's 3 columns because of something else that's in there. But I don't want the 3rd column, so I'm going to actually unselect the 3rd column. I'm going to select the 2 though, and I don't want to get it into table. I want column vectors. and I'm going to ignore that first line. And I told you that we're going to be interrupted every now and then with these names for the different plates, abbreviations for the plates. I'm going to rename these variables latitude and longitude now. Whoops, tude. Longitude. Okay. And I'm just going to go to the end and notice that MATLAB gives me a choice whether I want to come here, whether I want to exclude any rows that don't have the right data in them. Well, I don't, because I kind of want those place markers so I know where one plate ends and the next one begins. I certainly don't want to exclude a column that's missing some data, because then I'm going to exclude all of my data in this case. Or I could choose to replace any missing data with that I can't import into numbers, because that's what I'm choosing here, into not a number. When I get all done, I can come here and I can say, good, MATLAB. And you'll see it said that it just loaded in a bunch of data. That's great. But if I'm thinking about, maybe I want to run this as a report this month and next month and the month after and the month after, for our purposes, within a year or two, those plane boundaries are not really moving. And so I kind of don't want to go through this whole selection process of trying to read it in through here. But what I can choose here with the drop down for import selection is I can choose to generate a script or a function or a live script. I'm going to choose to generate a function right now. And you'll see this is the MATLAB code. It is a little after 11 a.m. here on October 7th. So it just generated this code. It says it's import file 1. You give it a file name, and you might give it optionally some lines to read. And then you can just read whatever you want here. This is the MATLAB code that's going to be that got generated. I'm going to ignore it for right now because I already saved a version of this. And I saved it in a file called import plates. And so I'm going to import the plates. And you'll notice that I'm also going to import some coastline data. And then what I'm going to do is I'm going to plot this using the Mapping Toolbox also on a world map. And this world map is going to have the coastlines on here. You can see the coastline of North America and South America and Africa and Antarctica and so on. And then I also have on top of there the boundaries, latitude and longitude here of the coasts. And so I'm plotting, that's what is in blue. So we can kind of see, here's the big North American plate, and this is the big African plate. Now, they look a little bit like the continents themselves, but of course they're not exact, because the boundaries of the coastlines is not the same as the boundaries of the plates. There are places where they are coincident, but it's just not always true. Well, if I want to, I can find that end of that first plate, because remember, I put that not a number, those nans in there. So I can find the first nan and just plot on top of this onto my plot in red the first plate, which in this case happened to be the African plate. Okay, so it's a really nice way for me to be able to pull through the data and be able to focus our attention on one region or another as we go. Okay, and I'm going to take the boundaries of our latitude and longitude that we just read in and make that into a geopoint. Geopoints are something that I'm using when I use that web browser. And so now I'm going to draw on top of our web browser the plate boundaries as well. I don't bother with the coastlines because we can kind of see them fairly easily. Now, one thing you'll notice here is that there seem to be earthquakes mostly, but not only, near plate boundaries. This is not surprising. That's where a lot of earthquakes come. I'm going to use my scroll wheel and zoom out a little bit right now. And you will notice there are some locations, for example, up here in the middle of Spain, where there was something that happened. It wasn't necessarily, it was 4.5. I don't know what it was. Does it tell me here? It says it was an earthquake. And we have things, for example, up in the Himalayas that are plate boundaries, are near plate boundaries, but they're certainly not near edges of continents or anything like that. And so you can go along here and find out much more information by zooming in, getting the information, or overlaying extra information that you would like to see on there. And notice that when I did that, not only did I put the locations, but I used that same color scheme so that the yellow ones are higher magnitude earthquakes than the orange ones that are higher than the green ones, and so on. So we get a clue about what's going on by choosing how to portray the data on top of the map there. Okay, and I've been doing this in a live script, and if I wanted to, like I said, when I'm all done, I can come here, I come to the live editor, and I can do my save as. Let's do an export to Word, and sure, I'll put it there. We've got a live document that should, or not a live document, you will see I didn't take out my silly math from in there. I still get links that I can use, and it incorporates some of the plots. It doesn't know how to incorporate the plot here, but if I wanted to, I could capture those separately and put them in. And I had captured them another day, an earlier day, which is why there are versions of them in there. So I get to then share that with other people, however it makes sense. So I hope you see that with the in MATLAB, I can read in my data, I can do some analysis on the data, and I can make this very transparent by sharing the code with everyone, sharing the document without the code if I don't want to, and make it available. And it becomes reproducible because other people can run the same code. I'm going to come back to the slides for a minute here and say what I did. Well, you saw me, I loaded earthquake data from the web. And instead of having to download earthquake by earthquake, all the information for all the 450 or so earthquakes in the last month, I was able to use web read to just scrape that website and bring the information into MATLAB for myself so that then I could pull it apart from the structured data that it was. And I pulled it apart into a table so that we could sort it and visualize it and do other work with it. I then loaded in plate boundaries that we found from the web too, and I showed you how to generate the code that would let us do that. And I also loaded in coastline data that we ship as part of a demo in MATLAB. And then we were able to superpose all of those together on various kinds of maps. And I was using MATLAB and the Mapping Toolbox for that. Okay. And there's a lot of other relevant toolboxes for the geosciences. It really depends on what you're doing. If you're doing any sort of mapping, of course, Mapping Toolbox might be helpful. If you're doing a lot of imagery, you might find that in addition to Mapping Toolbox, either possibly image acquisition, but certainly image processing toolbox might be helpful. Statistics and machine learning toolbox might be helpful. More and more people are trying out machine learning techniques to analyze their data these days. That would be a potential avenue for you to go. And optimization toolbox, a lot of math-oriented toolboxes that you might take advantage of. And then there's other places that you can go look for information. So we keep a page. This is from, you can see the MATLAB 2014 documentation, so it was a long time ago. But if I come search here in MATLAB, let me go search in the documentation, scientific, whoops, format. Come on. And let me find my, here we go. Here's our page that has the different kinds of scientific data sets. And you'll see that we have NetCDF and the different kinds of HDF files, van der Leeuw files, CDF files, and so on. And there's just a lot of information that you can get by looking through here and finding out the different kinds of data sets. In addition to data sets kinds of data that we can read automatically in MATLAB, there's other people who have written capabilities for reading in other kinds of data sets. For example, the IRIS group has written irisfetch. And so if you, I actually have a link for it, I think in the next demo I'm going to do. I might not, but anyhow, irisfetch, you can get, NOAA has sources for data. So a lot of sources for data and then for reading the data. And so irisfetch is meant to be able to read data that they archive on the IRIS website. EarthCube is very interested in making sure you can get your data into everywhere, including MATLAB, same with NGDC and EarthScope and so on. Okay, and now I want to come to the next topic, which is, okay, it's fine. I can use this to understand a small amount of data, but what if I need to analyze a data set that is much larger? And so I want to think about that. And I have access to an historical seismic data set, and it's data that started in the early 1900s. And so some of the data is quite old and it's messy, and they didn't collect all the information back then that we collect now. And so there's issues with the actual data set. There's also issues potentially with the quality of the instruments that collected the data back then compared to data that gets collected now. And so what I'd like to do is see if there's any real value to this data set, and trying to see sort of what's happened over time. And it's really quite interesting because there's a lot of great information you can get from it. So I'm going to get rid of this particular demo. I'm going to come here on my quick access toolbar here. You'll notice that I have some favorites. This is maybe my favorite that I call CCC, and it's for clear, clears my workspace. CLC clears the command window, and close all force closes any figure windows that might be open. I don't really have it much open because I was running in a live script where the output mostly goes into the document itself. But I'm going to do that now, and I show you that there's nothing in my workspace. I'm going to close the variables editor because I don't think we need it right now. And I'm going to come over here. I'm going to click on the tab here for this file, and I'm going to right click because I want to change to that folder so that I can get access to the data set that's there. Now I also don't need my web map anymore, so I'm going to let it go away as well. And I don't need that anymore from the import tool. Okay, and now I want to come over to my big data set with the historical earthquakes, and I'm going to open this CSV file that we got with the historical data set. And you'll see here, and I can zoom, let me zoom in a bit. That's a little bit more than I want to zoom. So I want you to be able to see more. There's a whole bunch of comments at the top. And it says where to get the information from. And then eventually at line 57, we see labels for some columns and then a whole bunch of data here. And you can see my scroll bars near the top still. There's a fair amount of data here. And I would like to load that into MATLAB. Now what this data consists of, let me go back up to towards the top again and show you, is it consists of a lot of columns. It's going to give me a date and time all together, I believe. Let's just see. Yeah, date and time together. A latitude and longitude. So this is going to be, and a depth where we have one. So it's going to give me the hypocenter for the earthquake, and it's going to give me semi-major and minor axes in the strike, maybe. And it's going to tell me what it thinks the quality of the information of the semi-major and minor axes is, or the depth in this case, and the uncertainty, and the magnitude, and the quality of it, and uncertainty. Notice these qualities are C. If I scroll down, and I'm going to go a little bit here, you'll notice that some of the qualities are A and B as well. So not just C. And I might say, you know what? I don't want to monkey around with any of the data unless it's considered to be quality A. So I'm going to want to filter a lot of the information out here. But if we keep going, you'll see that there's a moment that I might get, and a lot of other information here. So I'd like to read this into MATLAB, but I don't need all the columns, and I don't need all the rows. So, and if I do read them all in, it may be so large that it would be at best cumbersome, and at worst, it might not even work. Okay, so what I'm going to do instead of just opening that file is I'm going to say, make this a data store. And what a data store is just, it's a reference to the file. and I'm telling it something about the file here. I'm going to say use comma as a delimiter, excuse me. The number of header lines is 56 because it wasn't until line 57 where we got the headers for the catalog. And if I run this here, you'll see it gives me a warning because it doesn't like the names of some of the things, because some of those columns had funny things in their first name, like spaces or underscores or things like that. And so we just modified the names to make them valid MATLAB names. And it gives me information about the different the file, what folder it's in, whether or not I can rename the variables, and lots of other information in here. So if you find that it's not something, if it's misconstruing something that you thought it should read a certain way, you can, before you go and commit to anything, you can change what it does. And here's what the preview shows me. It shows me the first 8 rows of the table. And so I get the first 8 dates and date times for the different earthquakes. I then also can see that it has latitude, longitude, and all those different columns all the way out here. And many of these at this point are not filled in. So we said by default, if you're going to read them in and there's nothing there, we put a nan in so that we know that the data are missing there. Now, I don't want all that information, as I said. So again, I'm just showing you a preview. I would like to tell it what subset of information I'd like to read. And so I'd like to select the variables, and I'm going to get the column that's date, latitude, longitude, depth, the quality for the depth, the magnitude for the depth, the moment, and the moment author. And I'm telling it for column 1, what format I want it to understand that year and date and everything in. And it's going to be 4 digits of year, a hyphen, months, days, hours, minutes, seconds, decimal seconds. And capital D says to MATLAB, make it a date. Then you'll see for columns 5, 1, 2, this is an interesting thing. 1, 2, 3, 4, 5. Wait a second. 5, 7, and 9. Oh, well, this is the whole table. 5. 5 is Q1, Q2 is 7, and the last one is, I say I want the author to be a string, that's fine. But you'll notice Q1 and Q2, I'm saying capital C. Well, if you happen to know formatting from reading files through whether it's Python or C++ or Java, you're used to lowercase c for a character. That's not what this is. This is categorical, because when I'm reading in these quality measures, I know I'm reading in A or B or C. And so I don't need to keep storing A or B or C. And imagine that it wasn't a string like that. And suppose it was excellent, fair, and good, or excellent, fair, and miserable, or something like that. I don't need to store each of those strings literally millions of times. I basically can can keep the categorization in mind, and basically it can, without having to store the full volume of every single incident of the string, I can get that same information in a categorical. And it means that reading in the data takes up a lot less space when I do that. So let me come here and let's select our variables. And then now let's take a preview. And the nice thing is, look at this, the preview, those C's still look like C's. So we know it's quality C, it's still very readable. So when you get a categorical variable, it knows about the categories it represents. And like I said, if we, instead of having ABC, had excellent, fair, miserable, we would see miserable there right now for C. Okay, now I still may be in a position where I can't load all the data in at once. I don't know, because I haven't tried to read all the data in yet. I'm just previewing it here. And it might be that there's more than I can comfortably chew on my local machine. And so what I'm going to do next is I'm going to say, let's assume that data set is tall. That's just pointing to the DS right now. Now, what tall allows me to do is take my data store and say, you know, if it's tall, you don't have to read it on all at once. You're going to read it a chunk at a time. And what I want to get is I just want to get the equations that have the first quality measure, Q_1, equal to A, Notice I don't have to do a stir comp. I can just say equal. And then the ones that are true there, I just index in and I get the earthquakes that are high quality. And MATLAB doesn't even run this whole section of code between the tall and the gather until it hits the gather. So it's not running a lot of code, but it has to do it twice. First, it needs to find out which ones are acceptable, which ones had the value A, which ones were true, and then pass through a second time and do the indexing for them. And so you can see it took us about 10 seconds to do that operation. But now I have here my EQ qual, and if we look in my workspace, I have 13,000 of them. So however many rows there were in that other table, I've got a lot less now. Okay, and I'm going to take my table, which had as a first column that date and time, and I'm going to convert it to a timetable. And the reason I'm doing this is because the time is important, but it's not measured data in the same way that the epicenter is and the quality of the moment and all that sort of stuff. So it's important. I need it, but it will allow me to do some other things that I'll show you in a minute. If I turn my table into a timetable, there's certain things we let you do with time that make it very convenient to work with this way. So now what I'm going to do is I'm going to just take my earthquakes that have high quality Q1, and I'm going to plot them here. And you'll see I'm not plotting them on a map. So it doesn't look like kind of a map, but you can kind of see there's the probably the beginning of the Ring of Fire on the West Coast, and you can come down. You can sort of see the trench off of the coast of South America, and you can see part of the Australia plate here. But this is not a map projection, so it's not really the best way to show some of this probably. Before I show it on a map, though, let's see what it looks like. Let me find out what the minimum and maximum time. Our earliest high quality earthquake was later than the first earthquake in that table. It's in 1914, and the most recent one was in December 2011. Okay, and so now let's make a histogram, and we're just going to count them by years. And here is the histogram. I'm going to minimize my tool strip so you can see this more now. So here I have a histogram by year of the number of earthquakes per year. Now, if I were with you in the room, I would ask people, were they worried? What were they worried about when they see a plot like this? And for the non-geoscientists, they're often a little bit alarmed at first that, or some of them are, that it seems to be that there's a growing number of earthquakes over time and they're getting worse and worse, more and more over time. Well, that's not true. What's true is that we're getting better measurements over time and we have more instruments over time. So we're able to see more and better and smaller earthquakes over time. Very few early on and much more now. Now, I might want to see what's the median time between quakes of high quality. And so I can do that. And I can either do it in terms of hours, minutes, seconds for the median, the max, and the min, or I can convert it basically into just kind of a big number of seconds for everything. Well, I think this format is a little bit easier to understand. My median time between high quality earthquakes is just under a day. This number of days is it's 5,400 days. So that's about 15 years, 14 or 15 years. And we sometimes have earthquakes as close as just a couple seconds. It would be interesting to look at the ones that are very close. Are they nearby one another or are they not? In other words, are they part of a swarm or perhaps aftershocks of something? These are the kind of questions you can begin to ask when you have the information about the date in there. Okay. Now, I'm going to check to see if the data are sorted in here and if they're regularly sampled. Well, they are sorted by date. That's good. But they're not regularly sampled. So I don't have one every 10 minutes or every hour or whatever. But we kind of knew that. And what I can do is I can just find the latest ones by picking a time range from basically the last 29 of the, I'm going to get the last 30 of these here by, or last 29 of them by taking the time range from the last one here, the last 29th one to the end. And here I get a subset, and here's the subset of them here. And when I put them in here, you'll see that I get, whoops, excuse me, I'm sorry. If I keep my mouse within this, you can see that I can scroll through the table and find out what's going on here. And I can see the most recent ones. And I can also see, and I don't know why you'd ask this particular question, but you know, which ones were within a few minutes of 10 a.m. And there were a few. Maybe you want to find out what happened near your house at that time. Could anyone feel it? I don't know. Okay, but let me come back and look at the earthquakes of high quality versus time again. And now instead of looking at them binned up, I'm going to look at individual ones, and I'm looking at the magnitude here. And what you see is we have a lot more lower magnitude earthquakes showing up now than previously, and that's because we have much better coverage in the world with that instrumentation, and the instruments that are out there are much more high quality in terms of the measurements they take. And it's not because I don't believe that the statistics have generally changed that much for them. And then if we're looking, we can see, well, there were some big earthquakes in 2010, 2011, 2000, I don't know if that's 6 or so, 1964, maybe another big one. So some big ones back there. And we can begin to delve into these if we want. But before I do that, I can say, well, I can look by year. Well, I can look by month as well, for example. So we could say, well, is there any seasonality to earthquakes? And here is what I get when I bin things by month, irrespective of year and location. Now, this isn't really seasonality because, of course, when it's spring in the northern hemisphere, it's autumn in the southern hemisphere and vice versa. But what you can see is that February has the lowest count. Well, it also has the lowest number of days. And so there's nothing so compelling in here to make me want to look at this any further. I haven't showed you, though, that while I'm in here with any of these, you'll notice that I can start doing things like, if I want to, I can zoom in. For example, I can zoom in on a couple decades in here. And when it zooms in, it offers to show me the code. So if I always want to do that, I can put the date and time right in there. And that will call it like that the next time if I want it. So MATLAB will let you explore, and then it will actually help you create the code that you need from it in much the same way that the import tool allowed me to create code from that import data. It made a script so that I could import that data or data like it again without having to revisit the import tool physically itself. Now, when I was creating this demo, which was a few years ago, my manager happened to walk into my office, and he and I share a love of Japan. And so he said, before he had only seen up to literally this last plot by month, and he said, well, what happens in Japan? And I said, well, I'm glad you asked. So what happened is I then took a subset of the data. I'm going to set some limits for a box, a latitude longitude box around Japan. And I found a study where they did some analysis of earthquakes in that region. And what I'm going to do is I'm going to pull out those earthquakes that lie between the two latitudes and the two longitudes. And those are going to be my earthquakes for Japan. And I'm just going to convert the depth so that it's negative values now. And I can find the largest earthquake here by just taking the largest magnitude. And when I do, because I'm indexing using smooth parens, I had a table before, I get a table now, but it's a table with just one row. But that's okay, it's still a table. And we find out it's March 11th, 2011, and its latitude and longitude is so on, and its magnitude was a magnitude 9. And indeed, if we plot it, I'm going to plot the earthquakes in a geo bubble onto a map in our latitude longitude area, and you can see we have the Japan regions, And the biggest earthquake is in here, and you can't tell because it's hidden right there, but it's underneath this mass of earthquakes, this bubble of earthquakes that are there right now. So that's one way I can visualize the earthquakes near Japan. But then I can actually put them on a map like I was using from Mapping Toolbox before. I'm going to load in some topography, basically an image of the topography of Japan, and I'm going to create a world map, but just for the latitude and longitudes that we wanted. And I'm going to overlay a color map, and I'm going to basically plot the earthquakes from Japan on this. And the earthquakes are being plotted in yellow. And the color bar here shows you elevation above sea level and then depth below sea level. And you can see that these are just the epicenters, showing the epicenters right now. And you can see we have a large number of larger dots kind of in an arc here. We also have them on the other side of Japan, but we have them in the arc parallel to this trench, the Japan trench here. Well, that's kind of interesting. And I can take my values here, which are in latitude and longitude, and I can basically convert them into local information. For using the reference ellipsoid, I can get the from the latitude, longitude into basically kilometers east, north, and the depth. And so I can make a plot now that's more localized. And here I'm just showing a 2D plot. I'm showing north versus east. And we can see indeed that we have the earthquakes going down. And that's kind of interesting. Here's our biggest one. It's going down and it's at a depth. It's not at a depth. It's actually a little bit above or near the surface here. No, this is north versus east. Excuse me. This isn't depth. This is just our biggest epicenter here. If I want to see the depth, what I can do is I can change to a 3D view. And when I do, I can see these same epicenters, now the hypocenters. And if I wish, I can come here and rotate this and see it in any other view I want. I don't want to change that. So in fact, I'm going to run this again just to get it back in the view we wanted. Because what I want to do is I want to pop this out. And the reason I want to pop this out is I want to share with you a diagram that someone else made in this particular journal here. From their journal article, they drew the Japan region, and they have a cross section as a function of depth here going down 200 kilometers. And they show from the trench going down, and then where the different earthquakes are. And so there's a whole bunch of shallow earthquakes in the crust, excuse me. And then you see a bunch of earthquakes that are on the top of the slab going down and a bunch of other earthquakes going down. And if I take this and we compare it side by side, you see that the historical data that we looked at very much mirrors this same behavior here. And so I've kind of verified that with the historical data that we have from this particular collection is rich enough that it actually can support the same hypothesis, even though the data is a different data set than was used by these people. I'm going to come back to my PowerPoint now. And what I just showed you now is I loaded a subset of data from a very large comma-separated value file. Remember, the data were messy, both because there was stuff missing and because there was some data that was deemed relatively lower quality. And I was able to show you how to read in just the portion we wanted, the high quality stuff, and just the columns we wanted. Instead of reading all 28 columns, we read about 6 or 8 columns in, I think. And from those data, we were able to plot the epicenters and do some exploration by looking at histograms by year and by month. And we were able to look at the data very near Japan. And finally, we were able to validate this data compared to data that had been published in the research article listed there. And I was using MATLAB and the Mapping Toolbox, although remember, I was not using the web map this time to help me out. I want to talk a little bit more about the big data because what I did there might have felt a little bit mysterious. So, if we think about big data, one of the things that we've tried to do is to make accessing big data for you really very much like accessing the data that you would otherwise access with a small number of changes, but basically writing the code you want to write. So you'll see here, I have some data here that says read table with a file, and I'm converting it to a timetable and doing some stuff, computing some means and standard deviations. If we look at this and I have a whole bunch of files, maybe I don't have pump data, but I have pump data 1, 2, and so on. What I'm going to do is I'm going to make a data store out of my collection of files. I'm going to say, make that a tall data set so that it will not be processed it will be processed one by one, but I won't have to manage that. The data store will manage that. And when I'm all done collecting the information, I gather the information, in fact, the mean and standard deviation back. But in the meantime, the table to timetable, all the code outside these highlighted blocks are the exact same as the data, the code that you wrote beforehand for your one data file. And so we've tried to make it very, very easy and efficient for you to go from a situation where you're working with a small data set and trying to understand and make sure you're doing the correct analysis to going, okay, I'm ready to do the full thing right now. And you don't have to much rewrite the code. You get to try it very easily by adding a small number of commands here. So tall is relatively new. It's a new data type for data that doesn't necessarily fit into memory at once. And let me tell you how it works. What we do is we break the data into chunks. And what I didn't tell you here is that I am actually running on my MATLAB with a parallel pool. This parallel pool is using 4 workers because I have 4 cores on my laptop here. And so what it's going to do is it's going to divide the data that was in our data set up into 4 chunks, and it's going to work on each of the 4 chunks or it's going to work on 4 chunks at a time. And then it's going to march down the list of chunks and gather whatever information we're trying to gather there, and then it will aggregate it when it's all done. The nice thing is that many other things understand the tall data set, data type, including a lot of the machine learning techniques, for example, in statistics and machine learning toolbox, and a lot of other functions in MATLAB. Furthermore, if I have access through MATLAB Parallel Server to a cluster or maybe the cloud, the chunks don't have to be living on my 4 cores here. If I connect in my session to the cluster or the cloud, it will do the same thing by taking chunks in not just my local machine, but in the cluster or the cloud, and it will process things in the same way that we're doing here. So things immediately scale up to a larger size once you're ready to tackle the large data set. Okay, and I'm not going to really go through this example right now. I think I've talked about tall arrays enough. But one thing that's nice is you can also visualize tall arrays. Even if the data is not all loaded at once, it can load in some. And once it's loaded in as much as you want, you can come here and you can do things like, I want to see a little more detail. And so you can zoom in. And if you're ready to, you can then start panning. And the panning will potentially cause more processing of the data, getting more of the data in as you go. And there's more different kinds of support for tall visualizations over time, and you can look that up in the documentation, in the release notes. We also have some working with tall arrays and customizing it if you can't use the tall arrays straight out of the box the way we have it. And you can also export some of these capabilities very easily too. I'm going to now finish a little bit on community resources. I hope you know that there's a big active community on MATLAB Central. There's MATLAB Answers, where people ask and answer questions all the time. It's very active. The mean time to an answer is something slightly over an hour. I think that was the last time I looked. There's our file exchange where people donate code and other people take code and use it. We have a bunch of blogs, including my blog. We have Cody, and we have ThingSpeak, where you can work with Internet of Things and devices that are connected and explore the data online. There's also a global community in terms of the geosciences, and I'm just pointing to a few of the things. There's GMT for MATLAB users. Some people prefer to map to plot their maps with that rather than MATLAB Mapping Toolbox. There's Gizmo for doing seismic analysis. There's irisfetch that I mentioned, and there's also a CERC research page for educators. For any of you who are teaching geosciences, there's a lot of good teaching modules and examples to show and problem sets for people to mull over there. So I hope you enjoyed this today. I hope you learned a lot. I hope you learned that we have a lot of support for your work in geosciences, including from the beginning to the end, from getting your data in, doing all the math and visualization and mapping sorts of things you need to do, whether it's on a large data set or not, connecting you to the community. And so I would like to thank you for watching. We're going to put links in the description below on the YouTube page that you might find interesting. I want to point out two in particular. One of these is the MATLAB Expo 2020 it's available on demand, and it features technical talks covering a broad range of topics where MathWorks products play a central role. And if you're interested in Simulink, you might be interested to learn about the Simulink Student Challenge, where if you put in the winning selection, you may win $1,000. And I'm going to go over, there's a question. Juan asks, if you have a time component that are serially dependent, is it possible to use tall arrays? I don't understand the question. I'm sorry. If you could take a moment and ask it maybe a little bit differently, I'd be happy to try it out, though. Let me know if there's any update on that. In the meantime, again, I want to remind you finally to subscribe to the MathWorks channel to get reminders for the next events. I'm doing another 6 of these in the next 6 weeks, and they'll remain online so you can watch them again if you need to. Okay, and so one of the questions is, can you import map extents with good zoom resolution? We have some ways, you can look in the documentation, we have some ways of importing some other kinds of overlays, if you will, for the maps that are higher resolution. And so you can do that. It's in the documentation how you do it. Great question. Thank you for asking that. And with that, I think we're finished. Thanks so much.